Okay, this is chapter 3. This first section, 3.1, is about solving a system of equations by graphing, substitution, and elimination. There are 3 possibilities of your solution. So you could have 2 lines that intersect, which means there's one solution, and that's where they cross. You could have 2 lines that are the same exact line, just on top of one another, so that means infinitely many solutions because all the points are the same. Or if you have parallel lines, they have so much in common, but it's a shame they'll never meet, and that means there is no solution for parallel lines. So the first concept we're going to talk about is graphing. And we kind of talked about this when we were reviewing for the keystone, but let's solve an equation or system of equations by graphing. So you want to graph both lines on the graph and see if they cross or kind of analyze their solution. So first we need them in slope-intercept form. So they need to be in that y equals mx plus b form. So sometimes it's already written like that, and sometimes we need to solve for it. So if I take the first one, x plus y equals -3, and I solve for y, you're going to subtract x from both sides, and this is going to be y equals -x minus 3. So I'm going to graph this one in blue. This means you go down to -3 on the y-axis for the y-intercept, and it has a -1 slope, so it's going to rise 1 and to the left 1. And I put enough points to get me completely off the graph. That way when you draw your straight line, try to use like a straight edge of some sort, our textbook, another piece of paper. It's really important to draw straight lines when you're graphing a system. So let's look at the other one. The other equation was 3x minus 2y equals -4. So first thing you're going to do is subtract the 3x on the other side. So I'm going to bring it over there, and then you're going to divide each piece by a -2. So this is y equals a negative over a negative is just a positive 3/2 x slope, and this becomes +2. So this is my second equation that I'm going to graph in red. So I'm going to go to +2 on the y-axis. The slope is at positive 3/2, so that means rise up 3, run to the right 2. And likewise, you can go down 3 and to the right. Or I'm sorry, the left. I'm going to take my straight edge and draw a straight line through those. So you can see where they meet is this point right here. And that ordered pair as a solution is the point -2, -1. So this is the solution. They intersected at one spot. So I'm going to have you try number 2. We'll check this tomorrow in class. I will do number 3, and I want you to try number 4. So I'm going to do the odds, and you can do the evens. So let's look at number 3. 2x minus 3y is equal to -12. I got to solve for y first. So you're going to subtract the 2x, bring that to the other side, and divide all pieces by a -3. This is y equals positive 2/3 x plus 4. So I'm going to graph this in orange. So 4 on my y-axis, positive 2/3 slope. Kind of goes off the graph there. So let's click orange. There's my first line. All right, let's go green for the second one. 2x minus 3y equals -3. So kind of similar, you're going to subtract the 2x to bring it to the opposite side. Divide everything by a -3. This is y equals positive 2/3 x plus 1. I'm going to go to positive 1. The slope is 2/3. So you should see, even before I graphed these, that these are parallel lines. They have the same slope there of 2/3. So you're going to see that because they are parallel, there is no solution to this one because they never intersect. So that's the solution to that one. There is none. All right, like I said, you try number 4 because I want to try to keep this video as short as possible. All right, then we get into the substitution method. So think about if I called in sick, a substitute has to take my spot. So step 1, solve one equation for one of the variables. So sometimes that's already written for you, and sometimes you have to do a little bit of work to get one of the variables alone. Then you're going to substitute the resulting expression into the other equation to replace that variable and then solve that equation. And then in the end, you got to substitute what you got into the original and you can find the other one. So whatever you get has to work for both equations here. So if we look, 5x minus 3y equals 23, 2x plus y equals 7. None of the variables are, I say, home alone. Okay, there's none of them are stick at home, but I can see that the second one, that second equation for y doesn't have a coefficient. So I could easily rewrite this for y by subtracting the 2x over. So that is the same one. So if y called in sick, its substitute is negative 2x plus 7, and I'm going to put that in for the y in the top equation. So I'm going to have 5x minus 3. Instead of the y, the negative 2x plus 7 takes its place, and I set it equal to 23. And we're going to solve this, and you guys have strong equation skills, so I'll go kind of fast here. 5x, this is plus 6x minus 21 equals 23. Combine like terms. These make 11x's minus 21 equals 23. Add 21 to both sides. 11x is equal to 44. And if you divide by 11, you'll get x is 4. So that's the x value. Now, given that, you have to take that x value and go back up your choice, one of the two original ones, to find y. So I'm going to use that second one. It's a little bit easier. 2x plus y equals 7. I'm replacing my x with a 4 that I just found out and solving for y this time. So 2 times 4 is 8. Subtract the 8. Y is going to be negative 1. So your solution, and make sure you always write this as an ordered pair if it has one, is 4, negative 1. So that's like your xy ordered pair. Now it does say to check, so let's show you what that looks like. In the two original problems, or two original equations, I'm going to write them down here. Remember, the 4, negative 1 needs to be checked in both. So 5x minus 3y equals 23. That was the first one. And the other one was 2x plus y equals 7. So I'm going to replace the x with a 4, my y with the negative 1, and I want to see if that equals 23. So that's 20. This is plus 3. So 23 does equal 23. So it checked in the first one. So likewise, x gets replaced with a 4. Y is a minus 1. So this is 8 minus 1, which is 7. 7 equals 7. That checked out. So it has to work in both equations. All right, so you try this one. We'll check that answer. I'll probably request for your answer in Delta Math to see how we did. All right, then elimination. I like the elimination method better. Some students think it's easier. Sometimes you have to multiply one or both equations by a number to get opposite terms. And then you add the equations, eliminating a variable, solve it, and do what we did before. So if I look at these two equations, I already see that I have opposite coefficients in the x. One's a 2, one's a negative 2. So I'm just going to start by writing these two down. And we're going to add these two lines. Because I have opposites right here, that makes 0. If you combine your y terms, you have a negative 9 plus a 6, which gives you a negative 3y. And you do have to put these two together as well. So 34 minus 28 is 6. And then little easy one step, divide by negative 3. Y is negative 2. So then we're going to take that negative 2 and substitute it back into the one of the two originals. Doesn't matter which one. I'll just use the top one. So we found y is 2. So I'm going to replace y with a 2. This is 2x minus 18 equals 34. Oops, sorry, though. Made a mistake here. Y should be a negative 2 down there. So this is a plus 18. You subtract 18 from both sides. You get 2x is equal to 16. Divide by 2. X should be an 8. So again, write your solution as an ordered pair. X comma y, it should be 8 comma negative 2. And it does say check, so I trust that you know how to do that. I'm gonna move on to keep the video as short as I can here. So you try this one by elimination. So you don't have opposites right away, so you have to multiply a line by something to make opposites there. And then last, we have two special types of solutions. So I can use elimination because all my x's and y's are lined up. They all have coefficients. So I'm going to take this top equation and I need to multiply it by a negative 5 to get some opposites. Or I'm sorry, not negative 5, a negative 3. So that means that first equation is going to be multiplied, all three pieces, by negative 3. So that's negative 15 minus y, 9y equals negative 156. I should have an x there. 15x plus 9y equals 54 was the bottom one. You did not change. So I'm going to add these two together. You can see that the x's are opposites. They cancel out. But look, the y's are opposites as well. They cancel out. So you have nothing left on that side. And over here you have negative 102 if you put these two together. And we should see that this is not true. 0 is never equal to negative 102. So this has no solution. On the second one, if I multiply the top by a negative 3, to get opposite coefficients, you have, let's see, negative 6x minus 9y equals negative 15, and the bottom one that you don't change underneath it. Now watch what happens here. If I try to add these two, the x's, 6 and negative 6, make 0. The y's, 9 and negative 9, also make 0. And then over here, if you put the 15 and the negative 15 together, that's also 0. And 0 actually equals 0. That is true. So this is all real numbers, or we say infinite many solutions. All right, so that wraps wraps it up. We'll talk about the wrap up tomorrow, and as well as check some of these U-Try questions that you had to do and put your answers into Delta Math for the ones that I asked for. All right, see ya tomorrow.